Hey y'all, it's Dr. D. It's good to be with you again. We are in stoppage time. We are in bonus content. Had a conversation with a friend and remembered a thought that I'd had a while back. I shared it with one of my classes, but I wanted to get it down for posterity and share it with you. I think it's really useful to think about the ways that we observe data in real life and we interpret that data. And if we're not careful about understanding the data generating processes that we run into, and the fact that these are non-random processes, right? Then sometimes we can really draw the wrong conclusions. So the question I want to address today is there such a thing as a math person? And one reason why we're all wrong about a lot. So I know that certainly growing up, I can't speak for anybody but myself, but I definitely thought that there were some people who were math people, and then there were some people who were artsy, and that there was this trade-off there, right? That if you had this access to creativity, maybe you weren't an analytical thinker or whatever. And I think a lot of people pigeonhole themselves as a result of this process and cut off avenues of growth, maybe because they think, oh, well, that was never really my thing, and maybe believe in this kind of notion, what some people call a fixed mindset, right? That people are a certain way, and that they can't really change, right? It's an opposition to a growth mindset. And I'll say what I have found is that a growth mindset is both more true and more useful. And so I want to encourage you to get rid of this notion that there's a certain type of person. Some people are good at stuff and that's never going to change. It's just the evidence does not really back it up. And I want to talk about why we might think that it does, even though that's not correct, right? I'll say that in thinking that it does, what you're doing is a really good job, right? You're observing the data around you, you're drawing conclusions, you're making inferences, and it's a really powerful set of tools that you're applying. It's just that sometimes they lead you down blind alleys, and one thing I sometimes say is, you don't have to believe everything you think. So it's worth noting that, right? You have good thoughts, but you don't have to believe everything you think. Every one of your thoughts is worth spending time with, trying to decide, is this one of the thoughts that I want to keep? Or is this something that maybe isn't, I stumbled across because it seemed like a good idea at the time, or somebody I trusted told it to me. But honestly, I don't actually think it's true, right? So you don't have to believe everything. Now, why might you think? Let's think about this. Let's just do like math versus English, and I set it up this way because before I became an economist, I was an English major. Before I became an English major, I was a computer science major. Before I was a computer science major in school, I was like a math lead at an academic team. But I was also really good. I was a pretty decent writer. But there always felt like there was this. There were math kids and there were English kids, meaning writing, literature, maybe, and you can just substitute arts here if you want. And then you can substitute tech here if you want, something like that. But if we wanted to try to depict what this might look like, right? Let's say we've got math here, and then we've got English here as on the SAT scores or something like that. And the notion that's kind of at the root of this is that there's some fundamental trade-off, that if we took each individual person and we plotted them, what we would get is something that looks, it's noisy. Different people get different scores. But you get something that looks more or less like this. Right? If you were to scatter plot people, you get something that looks like this. Where if you were to draw a line through it, what you see is that if you score higher in math, then chances are you score lower in English, right? If you were to draw a line of fit through the data, this is the notion. This is the math person, English person hypothesis. It says that this is fundamentally the way the world works. There's a group of people, and they're all set up in particular ways, such that some people are better and worse at both or whatever. But on average, if you're better at math, you're worse at English, and vice versa. Right? So now, why might you think this is true, even if it's not even if it's not? Well, one reason is that people tend to hang out with people who, in the aggregate, have a similar level of capacity, right? And it does turn out that in practice, there can be a trade-off between strategies, right? So let's say that you are facing a problem, right? Now, what you might do is you might take a technical solution to that problem, or you might take a creative solution to that problem. And there might be a trade-off, right? Meaning that two people might have the same underlying level of ability, and some people might, they might be able to get out of the same set of situations or advance themselves through the same set of situations. But it might be the case, in fact, that like, let's imagine that actually what the cloud of everybody looks like is just noise, right? Everybody is just randomly assigned a math score and randomly assigned an English score. It could also, in fact, be the case that on average, the better you are at math, the more likely you are to be good at English. To do that, I'm going to have to fill in quite a lot of dots because this is like a very noisy data set right now. But if you were to draw a line through this, you probably would find just like no underlying relationship, right? Some people are good at some things, some people are good at other things. On average, I actually think it's more likely that you have people kind of something like this, right? So why might people, even if, let's imagine that none of these are, these are all gone. Let's see, can I erase these? And so we really do have this underlying relationship where there's actually a positive relationship. Again, it's very noisy, right? You can see it's very noisy. But if we were to draw a line through the actual data, let's assume this is the actual data, it would be upward sloping. If that were the case, why would people believe that there's this underlying trade-off? Well, one reason might be things like admissions tests, right? So it might be that in order to get to a certain school or into an honors program or to college prep classes or something like that, your combined math plus English score has to meet some certain criteria. Well, if that's true, then what happens is when we sort the data, right, or when we sort people into these groups, whether we should or not, that's a totally different topic, but as a matter of fact, we do. What happens is everybody who falls below this threshold, right, goes into one group of people, and everybody who falls below this threshold, right, or whatever, below goes into this other group of people, and so we essentially just sort people along these like 45-degree lines of like within this tranche you're in, and maybe this is like something like AP classes or PhD programs or honors or something like that, and then you've got like college prep and so on and so forth, right? Where each of these tranches is a group of people that are clustered together. Well, then when you look around, if you're in the honors program or you're in the college prep program, not quite honors, when you look around, these are the people you see, right? And so when you're collecting data to try to understand, like, where do I fit and how does the world function, what happens is that the people around you, let's say you're this person. If you're this person right here, what you'll say is, wow, all the people I know who are better than me in English, right? Which is to say up here, they're mostly, the vast majority of them are worse than me at math. Right? Now, if I could see all of society, right, if I had access to everybody, what I would see is that all of the people who are better than me at English, which is to say above me, right here, like some of them are worse than me at math, but some of them are better than me at math, right? And there's not, it's not obvious that being better at English makes me better at or worse at math. I mean, in this case, this is somebody who is quite good at math and not great at English, but somebody who's like the average person right here, like what they would see is, that actually, if you're better than me at English, you're probably also better than me at math. And if you're worse than me at English, you're also worse than me at math. And the reason why we don't see that is because the structures that surround us, the school system, school structures our experience. And not just school, right? Institutions in general. Institutions structure our experience, which is to say, right, when we look at prices, we look at markets, we look at human behavior, all of those things are socially embedded experiences that affect the way that we collect data, right? We construct a set of restrictions on the data that we observe, and that set of restrictions changes the representativeness of that data. And so within any given tranche of people, right, you do have this effect where there is a downward sloping relationship within your within your peer group, right? Within your peer group, there's a trade-off between math and English, but within the population as a whole, it is not the case. This is a well-known phenomenon. It's called Simpson's paradox. And it has to do with the idea that if you select subsamples of data, you can get the opposite, right? So if we estimated that slope term, you could have the true beta 1 be positive, whereas all your beta 1s are negative. Beta 1 for each group is negative. And that's a problem, right? Because it means that everybody is operating under this false assumption. And that means that guidance counselors and teachers are telling their students, all the students that I see, if I teach in an honors program, all the students that I see, if they're good at math, they're bad at English. If they're bad at math, they're good at English. And so if I find out you're good at something, I might tell you to avoid another topic, rather than realizing that actually maybe you are missorted or whatever, and you're good at both. And overall, really, the message that is worth sending is that it doesn't, in some level, it doesn't matter which you're good at. The fixed mindset says that wherever you are on this plot, this is about underlying ability, and you're going to stay there. But what I have found by looking at panel data and time series data and direct observation is that these numbers change, right? So people can change and learn. And the way that works is often by leveraging your strengths, whichever those are, to build more capacity. One thing that I have found has been incredibly true is that all of the things that I learned in my English program, they really helped me understand economics, right? Thinking from a perspective of narrative, right? What is the story? Can I embody the character? Can I capture the conflict and the tension, right? Anytime I'm facing a data analysis question, I really do try to think about who are the characters and what is their motivation and what is their conflict, and how can I use that information and that insight, that empathy, to try to understand what the options are that are available to them and the choices that they're making. Similarly, all of my economics and my math background really informed my English background, where it made me really good at close reading, right? Learning math really makes you a more precise and careful thinker, right? And so I became a poet because I was able to be very specific and picky and choosy about the words that I would use. And what I would say is, all of those strengths are going to make you better at both. That's really what the true underlying story here is that this is not fixed, and what happens if you believe in a growth mindset and you invest, you can move from here to here to here to here to here to here. You can get better at both of these things just by a slow and steady and concerted study of yourself and the work that you're doing, right? And other people who can guide you along that path, finding good mentors and leaders. So I would encourage all of you, question those assumptions you have about what your limitations are. It's possible that the reason that you have those assumptions or that you have those beliefs is because of faulty data, right? You've seen things in your life, or you have data that is there's a process of selection, right? That's part of what's going on here, right? Is that there's selection bias. And the data you have is not necessarily representative. It doesn't mean that it's not useful. It just means that you have to really, again, not believe everything you think. All right, I hope you thought that was useful. What I will say is, all of you, I've seen so many of you come to me and say, I'm not really a math person, this is not really my thing, and then you thrive. And so I hope that that's true in other areas of your life where you think, maybe this just isn't my thing. Maybe it's not, but maybe it is, and you just don't know it yet. You haven't found the right teacher or the right motivation. And I hope for you that you do find that motivation, that you do find the mentors and the teachers that will guide you on. There's so much out there. I hope you stay hungry and keep learning. And if you find something new and you know that I'm wrong about something, please come back and tell me. That's how I stay growing, right? People come back and they tell me, hey, I learned a new thing and I want to share it with you. I'm always grateful for that. Anyway, I'm Dr. D. I hope you enjoyed this video. If you have some things to teach me, I'm happy to learn from you. If you want to learn some more things and you want me to make another video, please let me know. And I will see you guys next time. Bye.